Hi all, welcome to new class. Today's class is the continuation of string efficiency, that is problems related to string efficiency. So today's class is about the problems related to the guard rings connected to these insulators. So let us go through the problems. The self-capacitance of each unit in a string of 3 suspension insulators is C. The shunting capacitance of the connecting metal work of each insulator to earth is 0.15 C, while for the line it is 0.1 C. Calculate the voltage across each insulator as a percentage of line voltage to earth and also the string efficiency. So in the question it is given that the self capacitance is C. So self capacitance is this one. So it is given as C itself. Then shunting capacitance of the connecting metal of each insulator to earth. So insulator to earth, that means it is this capacitance. So in the case of guard rings, there are two shunt capacitances. So one is the metal connection to the earth or the tower and the other is to the line. So here the shunting capacitance of connecting metal work of each insulator to earth means it is, this one is given as 0.15 C. So this is 0.15 C. And while for the line it is 0.1 C. So metal work to the line. So this is metal work to line capacitance. So it is given as 0.1 C. So this is 0.1 C. And the question is to find the voltage across each insulator as a percentage of the line voltage to earth and also the string efficiency. And here let A and B be the two junctions here. Then I1, I2, I3, the currents through these capacitances, and I1 dash, I2 dash, the currents through these two capacitors. Then capital I1, I2, I3 through the self capacitances. Then V1, V2, V3 are the voltage distributions across each insulator. Now we can apply the KCL at junction A. So KCL at junction A, then what will happen? So I2 and I1 dash are flowing towards the junction and I1, capital I1 flowing away from the junction. So we can write I2 plus I1 dash is equal to small I1 plus capital I1. Then what is I2? So I2 is V2 into omega C. Then plus, what is I1 dash? So I1 dash is equal to voltage into the reactance. So what is the voltage across that shunt capacitor? So here the voltage across this capacitor is the voltage between this point and this point. So it is equal to V2 plus V3. So voltage across this capacitor is voltage between this point and this point. So it is the sum of these two voltages. Similarly, the voltage across this capacitor is voltage between this point and this point, and that is equal to V3. So here I1 dash is equal to voltage is V2 plus V3 into omega into C, and that is 0.1 C. Omega into 0.1 C equal to, what is I1? I1 is V1 into omega into 0.15 C, then plus I1 is V1 into omega C. So I1 is V1 omega C. Then here omega C we can cancel. Then we will get V2 plus V3 into 0.1 equal to here 0.15 V1 plus V1. Now we can rearrange this one and we will get V3, that is 0.1 V3 is equal to, here this V2 is 1 V2 is here and 0.1 V2 is here, then we will get 1.1 V2 and here also 1.15 V1 minus 1.1 V2. So from here we can write V3 is equal to, dividing by 0.1, we will get 11.5 V1 minus 11 V2. So this is first equation. Now applying KCL at junction B. So at junction B, we will get I3 plus small I3 dash. Sorry, I2 dash. I3 plus I2 dash is equal to small I2 plus capital I2. So what is I3? So I3 is equal to V3 into omega C plus what is I2 dash? I2 dash is V3 into omega into 0.1 C, that is equal to I2. Then what is I2? The voltage across that capacitor is V1 plus V2. So V1 plus V2 into 0.15 C. Then plus capital I2 is V2 into omega C. So here we can cancel omega C. So we will get V3 plus 0.1 V3. So 0.1 V3 equal to V1 plus V2 into 0.15 plus V2. Now we can rearrange this one. So here 0.15 V2 and V2 is here. So 1.15 V2. So after rearranging, we will get here 1.1 V3 equal to 1.15 V2 plus 0.15 V1. So this is equation 2. So these are the two equations. Now here we have to find the values of V2 and V3 in terms of V1. So for that, substitute the value of V3 from 1 to equation number 2, that is V3, put V3 in equation number 2. So here we will get 1.1 into 11.5 V1 minus 11 V2 equal to 1.15 V2 plus 0.15 V1. Now we can rearrange this one. So we will get 13.25 V2 is equal to 12.5 V1. Then V2 is equal to 12.5 divided by 13.25 V1. So this is equation number 3. Now we can put the value of V2 in equation 1 to find the value of V3 in terms of V1. So put V2 in equation 1. So we will get V3 is equal to 11.5 V1 minus 11 into 12.5 divided by 13.25 into V1. Now here we can rearrange. So we will get it as 14.8 divided by 13.25 V1. So this is equation number 4. So V3 is equal to this one. Now we can find the total voltage. So total voltage is V is equal to V1 plus V2 plus V3, and here adding these equations, that is V1 plus then equation number 3, then equation number 4, then we will get V1 plus 12.5 divided by 13.25 V1 plus 14.8 divided by 13.25 V1 equal to, so after adding this we will get total voltage is 40.55 divided by 13.25 V1, that much volts. So these are the values obtained. So from this one we can find the value of V1. So V1 is equal to 13.25 divided by 40.55 V, and that is equal to 0.326 V volts. Then what is V2? So V2 is equal to, substitute the value of V1 here, that is 12.5 divided by 13.25 into V1. So V1 is 0.326 and we will get 0.307 V volts. Then what is V3? So V3 is 14.8 divided by 13.25 into V1. So here V is there and that is equal to 0.364 V volts. So these are the values of V1, V2 and V3 obtained. Then we can find the voltage across each insulator as a percentage of the line voltage to earth. So line voltage to earth means it is V. So we can find the percentage of voltage. So from the top unit, that is voltage across the top unit. Top unit is equal to, that voltage is V1. So V1 divided by total voltage, that is V. V1 divided by V into 100. Then what is V1? So V1 is 0.36 V. So 0.36326 V divided by V into 100. So it is 32.6%. Now second voltage drop across the second unit is equal to V2 divided by V into 100, and here V2 is 0.307 V divided by 100 and we will get 30.7%. Then for the across the third unit, V3 divided by V into 100 and that is equal to, V3 is this one, so 36.4%. So these are the voltage across each insulator as a percentage of the line voltage to earth. So line voltage to earth means it is the string voltage V. Next question is to find the string efficiency. So what is string efficiency? So string efficiency is equal to total voltage. So total voltage is V divided by number of disc into V3. V3 is 0.364 V into 100 and we will get it as 91.5%. So this is the string efficiency. So in the case of gartering, we have to do the problems like this. That is, here it is given the shunt capacitance for the line. That is, shunt capacitance between the line and metal work is given. So that means there is a gartering. Let us do another problem. Each line of a three-phase system is suspended by a string of three identical insulators of self-capacitance C farad. The shunt capacitance of connecting metal work of each insulator is 0.2 C to earth and 0.1 C to line. Calculate the string efficiency of the system. If a gartering increases the capacitance to the line of metal work of the lowest insulator to 0.3 C. So here the self-capacitance is given as C farad. Then shunt capacitance of connecting metal work of each insulator is 0.2 C to earth. So that means it is this one. So this is 0.2 C. Then point 1 C to line. So point 1 C to line means metal to line. So this is point 1 C. And it is given a guard ring increases the capacitance to line of metalwork. So capacitance to line of metalwork means this capacitance of the lowest insulator to 0.3 C. So lowest insulator means this one. So it is increased to 0.3 C. Find the string efficiency. So here we have to find the string efficiency. So here at node A, applying KCL, then we will get I2, capital I2 plus I1 dash is equal to small I1 plus capital I1. So I2 is C, that is V2 into omega C plus I1 dash is V2 plus V3 into omega into 0.1 C equal to I1 is V1 into omega into 0.2 C, then plus what is I1? I1 is V1 omega C. Now omega C we can cancel, then we will get V2 plus V3 into 0.1 equal to 0.2 V1 plus V1. So here we can rearrange this one and we will get V3 is equal to 12 V1 minus 11 V2. So this is equation 1. Similarly at node B, applying KCL, then we will get I3 plus I2 dash equal to I2 plus capital I2. So I3 is V3 into omega C plus I2 dash is, so I2 dash is V3 into omega into 0.3 C equal to I2. So what is I2? I2 is V1 plus V2 into omega into 0.2 C. Then what is I2? I2 is V2 into omega C. So I2 is V2 omega C. Now here omega C we can cancel, and after rearranging we will get here 1.3 V3 is equal to 1.2 V2 plus 0.2 V1. So this is equation 2. Then put the value of V3 here. So V3 in equation 2 implies, so here we will get 1.3 into 12 V1 minus 11 V2 equal to 1.2 V2 plus 0.2 V1. Now after rearranging we will get 15.5 V2 equal to 15.4 V1. That is V2 is equal to 0.993 V1. So V2 is equal to 0.993 V1. Then to get the value of V3 in terms of V1, substitute the value of V2 in equation 1. So equation 1 implies we will get V3 is equal to 12 V1 minus 11 into 0.993 V1. So we will get 1.077 V1. So V3 and V2 in terms of V1 are obtained. Now we can find the total voltage. That is the voltage between the conductor and earth. That is the string voltage we can find. So voltage between the conductor and earth is V is equal to V1 plus V2 plus V3, and that is equal to V1 plus V2 is 0.993 V1 plus V3 is 1.077 V1. So that is equal to 3.07 V1. And the question is to find string efficiency only. So for that we need only the total voltage V and V3. So both are in terms of V1. So we can find the string efficiency is equal to total voltage divided by number of disc into V3. V3 is 1.077 V1 into 100. So we will get it as 95%. So string efficiency is equal to 95%. Let us do another problem. It is required to grade a string having 7 suspension insulators. If the pin to earth capacitance are all equal to C, determine the line to pin capacitance that would give the same voltage across each insulator of the string. So here there are 7 suspension insulators and it is given that pin to earth capacitance are equal to C. So pin to earth capacitance means it is the shunt capacitance. So here shunt capacitance is given as C. And also here we have to find the line to pin capacitance. So line to pin capacitance means, so this is the line to pin capacitance. So this shunt capacitance we have to find. So let these be C1, C2, C3, then C4, C5 and C6. So these shunt capacitance we have to find, and also given that the voltage across each insulator of the string are same. So voltage across each insulator are equal to V volts. So here shunt capacitance is given as C. So C1 is given as C. Then we have to find the value of this self capacitance. So C1 is given as C. Then what will be C? So shunt capacitance divided by self capacitance is equal to K. Then what will be the self capacitance? So self capacitance is equal to shunt capacitance divided by K. So shunt capacitance is C divided by K. So the value of self capacitance is equal to C divided by K. So all are equal to C by K. And here all the voltages are equal, so the current through these self capacitance are equal, so all values will be equal to I. So I1 equal to I2 equal to I3 equal to I4 equal to I5 equal to I6 equal to I7. So all the currents are equal. Then the current through these capacitors are I1, I2, then I3, I4, I5 and I6. Similarly, currents through these capacitors are I1 dash, I2 dash, then I3 dash, I4 dash, I5 dash, then I6 dash. So here all the currents are equal. I4 equal to I5 equal to I6 equal to I7. So let A, B, C, D, E and F are the junctions between each insulators. Then at junction A, applying the Kirchhoff's current law, then we will get I2, I2 plus I1 dash equal to small I1 plus capital I1, and here I2 and this capital I1 and I2 are equal, so we will get I1 dash equal to small I1. Then what is I1 dash? So between the junction A and the conductor there are 6 voltage drops. So I1 dash is equal to 6V, that is 6V into omega into C. C means C1. So omega C1 into 6V equal to what is I1? So I1 is V into omega C. So here we will get 6C1 is equal to C, or we can find C1 is equal to 1 by 6 C, and that is equal to 0.167 C. So C1 is equal to 0.167 C. Similarly, at junction B, we will get, so I3 and I2 are equal, so we can write I2 is equal to I2 dash. So what is I2? So I2 is 2V omega C equal to I2 dash is, now there are 5 voltage drops. So 5V omega C2. So here we will get C2 is equal to, so C2 is equal to 2 by 5 C, and that is equal to 0.4 C. Now at junction C, so at junction C, I3 is equal to I3 dash. So I3 is 3V omega C is equal to I3 dash is 4V omega C3. So C3 is equal to 3 by 4 C, and that is equal to 0.75 C. Similarly, at junction D, so at junction D, we will get I4 is equal to I4 dash. So I4 is equal to 4V omega C is equal to 3V omega C4. So what is C4? C4 is equal to 4 by 3 C, and that is equal to 1.33 C. Similarly, at junction E, we will get I5 is equal to I5 dash. So I5 is 5V omega C is equal to 2V omega C5. So C5 is equal to 5 by 2 C, and that is equal to 2.5 C. Similarly, at junction F, we will get I6 is equal to I6 dash, that is 6V omega C equal to V omega C6, that is C6 is equal to 6C. So these are the values of the capacitance, that is line to pin capacitance. C1 is equal to 0.167 C, then C2, then C3, C4, C5 and C6. So that is about the problems related to string efficiency and also including the guard ring. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.